Our young innovators are chosen every year from around the world. They're young partly because youth is cool, but mainly because we want to introduce you to young innovators whom you haven't met before and who are working on big problems. They are, as I said earlier, always some of the most inspiring parts of the day. And to me, what's most thrilling about them is the novelty and the ambition of their research. We have 5 to begin the day, and we're going to begin first with Steve Ramirez, whom I introduced you to in my opening remarks. Steve.
So my work focuses on finding single memories in the brain, tricking the brain cells that house those memories to respond to pulses of light, and then using light to either activate, inhibit, or create new memories in the brain. So now, every time you form a memory, there's a very specific subset of cells that are active during the formation of that memory. So what my team and I in lab did was we went in and first found those brain cells, and then we artificially installed a sort of light-sensitive switch into those cells so that we have optical leverage over the brain now. That's exactly what you're looking at right now. So this is a tiny cross-section of the brain filled with hundreds of thousands of brain cells. But the green brain cells are the ones that are holding on to a specific fear memory in this case. So what you're actually looking at is at the cross-section of a memory at the level of the brain. So here's our daily colleagues that we use and shoot light into their brain. Now, what we wanted to do is put this technology to the test. So we put our mice in this chamber here, and we gave them a couple of mild foot shocks so that they form a fear memory of this environment. Now, with our system, the cells that are active in the brain during the formation of this memory now become light sensitive. So the remarkable part is the video that Jason showed at the very beginning, was that we could take our mice now, place them in any given environment, shoot light into the brain, and reactivate that fear memory at our leisure. So this was the first demonstration that we could use optics, in this case, to reactivate a fear memory in the brain. So now that we can do that, we thought, well, can we reactivate a memory and change the contents of a memory? We called this one Project Inception. So we started by taking our mice and putting them in, let's say, a blue box, like this one here. We find the brain cells that are active during the formation of the memory of the blue box, and we make those brain cells light sensitive. The next day, we place the animals in a red box that they've never been in before, and then we can shoot light into the brain to reactivate the memory of the blue box. But the thing is that while this is happening, we simultaneously give the animals a couple of mild foot shocks. So we're trying to artificially form an association between the memory of the blue box and the foot shocks themselves. And to test if we had done so, we can put our animals back in the blue box where nothing bad had ever happened to them, and yet now they display prominent fear behavior. So they're falsely recalling being shocked here, even though, technically speaking, nothing bad ever happened in that box. So we had successfully created a kind of false memory in the brain. Everything that I've talked about so far has to do with activating memories, but we also have a light-sensitive off switch that can help us shut off memories. Imagine being able to optically shut off the traumatic components of PTSD or the debilitating components of depression. My name's Steve Ramirez, and I'm a grad student at MIT's Brain and Cognitive Science department. So ladies and gentlemen, I'm here today to inaugurate the era of artificial memory manipulation. Thank you.